Hello everyone. So in the last video we discussed about the basic opamp. In this case we are going to discuss about the ideal opamp. So as we can see in the diagram which is on the right hand side, we have two inputs and we have one output. Basically in the case of the ideal opamp, we will have the negligible resistance to the output load and we have an infinite resistance to the input load to the input terminals. So we can define here some ideal terminal conditions, that as rd is equal to infinity, that is the r input, and r naught is equal to 0. And if we have rd is equal to infinity, then in that case we can take ip and in is equal to 0. So these are some ideal conditions. So now we will discuss the properties, or we can say the ideal op-amp properties. So the first one is the infinite voltage gain. So any op-amp which is an ideal, which has a which has some infinite input resistance and zero output resistance, will definitely have an infinite voltage gain. The second one is the same that we have discussed, that is the infinite input resistance rd. So that is the rd is equal to infinite. Why this rd is equal to infinite? Because any signal source can drive it, so that is why rd should be infinite and there should be a no loading at the preceding stage. The next one is the zero output resistance. So we can drive as many number of the loads as we want. Next one is the zero output voltage whenever input is 0. And the next two, fifth and sixth points are the CMRR and slew rate. So these are the advanced topics that we will discuss later on. So the CMMR is the common mode rejection ratio. So I will tell here just the basic definition of CMRR. So it is the common voltage that has been applied to the two terminals. So it should be infinite. And slew rate is how our output voltage is changing with respect to time. So these both should be infinite. So next one is the non-ideal op-amp. So in case of ideal op-amp, we were talking about the infinite or zero resistances, but here we will have some finite resistance. That means this non-ideal case is exactly opposite of the ideal case. So this is opposite to the ideal op-amp, only the positive negative terminals are changing its position. So what is the difference here? It is that we have some resistances, that is R1 and R2, means there is some kind of feedback. So in this case our gain will be 1 plus R1 by R2, and we are applying our voltage source to the positive terminal, that means to the non-inverting terminal. So next we are going to discuss the characteristics of ideal op-amp. So we are just going to reverse all the characteristics that we have discussed in case of ideal op-amp. So we have here infinite input impedance, as in the case of the ideal one we were having the zero output impedance. So in the ideal case we were having the output impedance that was equal to infinite, but here it will be some low quantity, that will a number that will be very low. Next one is the very large voltage gain at low frequencies, and we have infinite bandwidth, and we are going to have the infinite common mode rejection ratio and infinite power supply rejection ratio. So both the ideal and non-ideal are exactly opposite of each other. So now we're going to discuss about the non-ideal op-amp. So here the open loop gain will be finite, input impedance will be finite, output impedance will be non-zero, CMR will be infinite, input resistance will be finite, there will be a finite bandwidth. So basically bandwidth is the width of the input of that op-amp, so that it can operate in that particular range. So next one is the finite power supply rejection ratio. So these were all about the ideal and non-ideal op-amp. Thank you.